Hi everyone, this is Neural Networks Part 2. In the previous one, we talked about x times w equals the prediction, and how far off is the prediction from the correct answer. And we call that the loss. We use the squared error loss because when we calculate the derivatives later, it'll make it work better than just subtraction. So here is the derivative of the loss with respect to y hat. Y hat is the prediction of the neural network. This is the derivative of y hat with respect to w. We chain the derivatives together to make the global derivative. dl dy hat is one of the local derivatives. dy hat dw is another local derivative. When we chain them together by multiplication, they become the global derivative. Now we can adjust the weights so it'll come up with the correct answer, whatever w is originally, minus 10% of the gradient, or 10% of the global derivative. Then we run the prediction again, run the loss again, and the loss should be lower this time. So I'll run this. Okay, the loss is 16. So if I run it again, now it's 10. We want the loss to be as close as possible to 0. Run it again. 6, 4, 2, 1. As you can see, the loss keeps getting lower and lower. Part of what that's saying is when we check y hat again, it'll be close to the correct answer because it doesn't have much loss. It's not far off from the correct answer. This is where this training of the neural network happens. One thing we could do, instead of running it over and over again, we could use a for loop. For I in range, let's run it 100 times. Go to here, indent all of this, highlight, hit tab, say print L, so print the loss. And we can see how it changes. I'm going to restart it up here. Okay, now run it. Okay, loss was 16, then 10, then 6, 4, 2, 1, and so on. I'll just do 20 times. Let's start over. So run it. Loss is 16, 10, 6, 4, 2, 1. It gets closer and closer to 0. Now if we run y hat, remember we wanted the prediction to be 7. X times w to be close to 7. But before it was 3 times 4 is 12. But we adjusted w so it would predict closer to 7. Now, since the loss is lower because of the training, we run it and it's really close to 7, 7.05. That is training a single part of a neural network, a single perceptron. Piecing a lot of those together in certain ways makes it where people can do things like image recognition. That combined with other things can make self-driving cars. That combined with the thing called a transformer can make things like ChatGPT, where GPT stands for Generative Pre-trained Transformer. This is one of the main core parts of a transformer. One of the main core parts of a neural network is the perceptron. Thanks for watching. Please click like and subscribe, and if you have any questions or comments, let me know. Thanks.